Good day. I'm Arvin Enriquez, your subject teacher in General Mathematics. With this visual lesson, we're going to discuss rational functions, equations, and inequalities under your General Mathematics from Quarter 1, Module 5. Our lesson objectives. At the end of this video lesson, you are expected to represent real-life situations using rational functions and distinguishes rational function, rational equations, and rational inequality. So let's deal now with this slide. So it's about representing real-life situations using rational functions. Here, rational functions can model several real-life situations. So not only rational functions, so it can be logarithmic function, exponential function, but in this video lesson, we're going to talk about how can we use rational functions to represent real-life situations. So one example is the help that is extended by the government to the citizen during the time of pandemic. So, as representation of this scenario, no, wherein the government extended the help to the citizen during this time of pandemic or amidst of this pandemic, we simply use rational functions to represent those things. Majority of our fellow citizens experience hardship, required help coming from the government. As a response, they provided a particular amount to a certain percentage of the population. So that can be represented as rational function to determine how much either in cash or kind an individual may receive. So by simply using your rational function, we can identify how much cash or in kind, no, an individual may receive. That will be dependent on the funds that our government will release and based on the number of citizens, no, who required the government or ask for for a help, no, from our government. So however, it is not enough that only the government would take part to solve this crisis. So everyone can be part of the solution if we played our role properly. So by simply looking, no, by this scenario, we can simply use your rational functions to represent the ratio, no, between the in cash or in kind an individual may receive and to the numbers of beneficiaries. But the thing is, we really need to do our part and be part of that solution by simply playing our role properly. So real life situations that involve rational functions is mostly seen in economics. So please do take note of this. That rational function is mostly seen in economics and science. However, no, other disciplines also incorporate this concept. If you wonder how rational function can help you, can explore this module. So let's have some review about your polynomials, your constant function, linear function, quadratic function, and your cubic function. Here, before moving forward to the concept of rational functions, let's have some recall or review about your polynomial. First thing to do is to deal with your constant function. So when we say constant functions, here there's a given f of x. And as you can see on the right side of this function, so there is a number without a variable attached to it. So meaning to say, if this is your given function, this function is called a constant function. Why? Because your degree, or the highest degree that you can see on this, is 0. Because there is no attachment of variable. So there is no x variable on it. For the linear functions, so this linear function, your highest degree is 1, wherein in reality there is 1 here as your exponent in your negative 2x raised to 1 plus 1. Most of these linear function, or these linear functions, represent an equation of a line. So when we say equation of line, it's a straight line. It can be rises from left to right, falls from left to right. Um, the direction must be upward, leftward, rightward, no? But this linear function represent a line wherein your f of x is equal to negative 2x plus 1, for example, wherein your highest degree that you can see, no, in the given polynomial is 1 here. Your exponent to x, or the exponent that you can see on the x variable, or the high exponent that you can see on the x variable, is only 1, or equal to 1. Now, moving forward with your quadratic function, wherein your highest exponent is 2, or highest degree that you can see on this given function is 2, wherein f of x now is equal to 3x squared minus 5x plus 2. This will be a good example of quadratic functions wherein your highest exponent in your leading term must be equal to 2. Before we consider that the function is a quadratic function, you need to look for the exponent of your leading term, which is 3x. If the exponent of 3x is equal to 2, then the given function now is a quadratic function. As long that the exponent of your leading term is equal to 2, then the given function is a quadratic function. Now moving forward with your cubic function, your highest exponent is 3. So as you can see here, there's an f of x is equal to 4x cubed plus 2x minus 7. So in your leading term, your highest exponent here is equal to 3, wherein this will be your leading term, which is your 4x. So the variable, or the exponent now attached to your x, must be equal to 3 before you consider that this given function is a cubic function. Regardless if we erase this 2x minus 7, as long that there is a term here, or your leading term, as long that there is a leading term wherein the exponent attached to your x variable is equal to 3, then the given function is a cubic function. The following are examples of rational functions. So right after dealing with your polynomials, your constant, your linear, your quadratic, and your cubic functions, no? Let's deal now with the concept, or the example of your rational functions. First example is that your r of x. As you can see here, any letter can be used as a function. It depends on you how you write it. As long that you know that this letter represents a function, then it's fine. A, B, C, or D can be a function. It's up to you. Again, it's up to you if what letter are you going to use to represent a function. Here, we use r to represent a function. That's why it's r of x is equal to x cubed minus 1 over x plus 1, wherein your x is equal to negative 1. So both numerator and denominator are polynomials. Yes, it is, no? Wherein your numerator here is a cubic function, and your denominator here is a linear function. So both your numerator and denominator are polynomial functions. Yes, it is, no? By simply checking on it, They are both polynomial functions. Denominator has restriction because it should not be equal to 0. So we need to check, no, this one should not be equal to -1. Your x here should not be equal to -1 because if that is -1, it makes sure a denominator equal to 0. So there is a restriction that we should make, no, or we need to make your denominator not equal to 0. If we put this -1 to this x, -1 plus 1 is 0. So we cannot put -1 as a value of your variable x here. That's why we need to look for another value of x wherein it can give you a value of denominator not equal to 0. You need to check those stuff, no? And you really need to look for a value of x that can give you a denominator value which are not equal to 0. Now, for number 2, same scenario. We use f of x to represent the function, so it can be r of x, s of x, p of x, so any letter can be a function. It depends on you, or it depends on your decision. What letter are you going to use, no, in representing a function, as long that you know what these letters are representing. So your f of x is equal to 1 of x, wherein your x is not equal to 0, because we really need to make sure that your denominator is not equal to 0. So it can be negative, so it can be positive number greater than 0, it can be less than 0, as long that your x is not equal to 0. So the denominator, numerator 1, is the polynomial function. It's a constant function. It is, no, with a degree of 0. The denominator is a polynomial function. Yes, no? Both your numerator and denominator are polynomial functions. Your numerator is a constant function. Your denominator here in example number 2 is a linear function. And it must not be equal to 0. So you need to check, no, if the denominator is not equal to 0. So here there is a restriction here wherein we need to look for the value of x which is not equal to 0. It can be less than to 0 or greater than 0, but not equal to 0 definitely, because it makes sure a denominator equal to 0. So there is a restriction again, no? In your polynomial, in your rational function, I means, you need to check first if your numerator and denominator are polynomials, and you need to make sure that you're going to put a value of x which can give you a value of denominator that is not equal to 0. There are two considerations. Check if your numerator and denominator are both polynomial functions. Then check if the value of x that you're going to put in your x variable can give you a value of 0. Then you need to look for another value of x that can provide you a value of your denominator which are not equal to 0. So there are different scenarios or real-life world relationships that can be modeled by rational functions. So let us take the following examples. So the local government unit allotted a budget of 100,000 pesos for the feeding program in the daycare center. The amount will be divided equally to all the pupils in the daycare center. So write an equation showing the relationship of the allotted amount per pupil. So represent by f of x. So we simply use f of x versus the total number of children represented by x. Showing the relationship in tabular form, we will arrive at, so the number of children, which is 10, 20, 50, 100, and 200. So allotted amount for child is 10,000, for the number of children, which is 10, then 5,000 for the 20 children, and 50 for 2,000 pesos, 100 for 1,000 pesos, and 200 children's for 500 pesos. Notice that as the number of children increase, the amount allocated per child decrease, no? As you can see, if this number of children increases, no, then the number of allotted amount per child decreases. So there's a relation between the number of child and the allotted amount per child, no? So you need to look for a function that will represent on this. So in writing a representation, we will arrive at f of x is equal to 100,000 over x, because the allotted amount for child will depend on the number of children, which is your x. That's why if the total, the allotted budget for this feeding program is 100,000, we need to divide this 100,000 by x, or the number of children that will serve as beneficiaries of these uh, 100,000 pesos. That's why your f of x now, or the function that will represent, no, this scenario is 100,000 over x. 100,000 as your allotted budget for this feeding program, and x is the number of children that we're going to subject for this feeding program. So this will be now the function that will represent this scenario. For example number 2, suppose a benefactor wants to supplement the budget allocated for each child by donating additional 50 pesos per child. If we use h of x to represent the new amount allotted per child, construct a function representing the relationship using the table we used earlier. So for the number of child here, so for the number which is 10, 20, 50, 100, and 200, so there is a allocated amount for child here. For 10, that is 10,000, 20 for 5,000, 50 for 200,000, 2,000, and 100 for 1,000, and 200 for 500 pesos. Now, we just simply put 650 on it, because there is a donating additional 650 pesos per child here. So there is a typographical error here. It should be 650 pesos. So not 750. So based on your problem, so there is additional 650 pesos per child. So what we're going to do is to add this 650 to the given function on our first example, which is 100,000 over x. Now we simply use your h of x, not g of x. So we simply use h of x here. Your h of x now is equal to 100,000 over x plus 650, not 750. So this 650 will represent the additional amount of money that each of the children will receive, no? Then we simply use h of x to represent these functions. So we simply use the value of your f of x for our first example, which is 100,000 over x. Then we just simply add 650, because 650 pesos is an additional amount that from the donations, no? The 650, regardless of how many children or that are being involved on this scenario, regardless of their numbers, they will all receive 650 pesos each. That's why our function here, which is h of x, we simply use your h of x. is equal to 100,000 over x, wherein your 100,000 is the only amount that is being cut, and that will be dependent, no, to the number of children being subjected. So whatever the amount or the resulting value from 100,000 over x, we just simply add this 650 as the additional donation for every child, and that will be the value of function h of x that will represent the new amount allotted per child. So for number 3, so a car is to travel 70 kilometers. Express the velocity b, so we simply use b to represent your velocity as a function of travel time, which is t, in hours. So let us first show the relationship using a table. So remember that as time increases in traveling, the velocity or the speed of car will decrease. So please do take note of this. Remember that as time increases, when your time increases in traveling, the velocity or the speed of car will decrease. So if there's a decrease in the speed and velocity of your car, there is an increase with the time you traveled with respect to your velocity and your speed. So with this one, so there's a given time here. So the unit of measure for your time is R. So 1 hour, 2 hours, 3 hours, 5 hours, and 10 hours. For the velocity that we travel for 1 hour, it is 70 kilometer per hour. So the speed or the velocity that we use is 70 kilometer per hour. And for the 2 hours, we simply use 75 kilometer per hour as your velocity. Same thing with 3 hours, 23.33 kilometer per hour, and 5 hours for 14 kilometer per hour, and 10 hours, for the 7 kilometers per hour. So this will be the speed, no, or velocity that we can map in each of the time given here. So thus the function b with respect to t now is equal to 10 over t, can represent b as a function of t. So we just simply divide this one. As you can see here, this is not 10. It should be 70. So this will be 70, not equal to 10. So your b of t now is equal to 70 over t. So that will be 70 over t. So the value of this function v of t with respect to t is now equal to 70 over t. So it depends on the time or how long you travel that particular distance. For example, no? So when your time increases, when your denominator increases, automatic the value of your velocity decreases. So that's how this function works, no? Because when your time increases or your denominator increases, it's automatic that the value of your fraction here that will represent your velocity with respect to time will decrease. And then the velocity with respect to your time will be dependent on the flow or the time we spend on our travel. So when your time increases, your velocity decreases. When your time decreases, then your velocities and speed increases. So it's a vice versa, no? So this function represent the travel of time in hours. So the express this velocity as a function of travel time in hours. So what will be the number of kilometers per hour we travel if your time increases and when your time decreases? So what will be the velocity that we can map on each of the time that we traveled of a specific distance? For example, in this problem, your specific distance is 70 kilometers. So for this slide, let's deal now with the rational equation, your rational inequality, and your rational functions. So your definition for your rational equation is an equation involving rational expression. So as you can see, there is an equation here wherein there's an involvement of equal sign. You need to look for this symbol which is your equal sign, and you need for uh, the involvement of your rational expression here. So there is a rational expression here which is your x plus 4 and x minus 1. As long that there is a rational expression on it, and the symbol between your left side and right side of this equation is an equal sign, then the given is a rational equation. First thing to consider is your equal sign here between your right side and your left side. So if the symbol between your right side and left side is an equal sign, plus there is an involvement of rational expression, then the example or the given is a rational equation. For the rational inequality, an inequality involving rational expression, as you can see here, the symbol between your right side and left side is greater than. So it can be less than, greater than, or not equal to. So as long that your symbol here between your right side and left side shows inequality, or it shows that your left side is not equal to your right side, and there is an involvement of rational expression which is x here, x minus 2 here, as long that your symbol between your right side and left side shows an equality and there is an involvement of rational expression, then your given is a rational inequality. For the rational function, you need to check if we follow this form wherein your q of x is also a polynomial and this q of x is not equal to 0, because we really need to make sure that your q of x is not equal to 0. So your p of x and your q of x are both polynomial functions, I mean, wherein your numerator and your denominator are both polynomials, and we need to check your denominator q of x supposed to be not equal to 0. It must be not equal to 0. That's why you need to look for the value of x that can give you a denominator not equal to 0 before you consider this one. So what are the considerations? So there is an equal sign between your left side and right side, and there's a function f of x here. So we substitute y as a value of your f of x here. We can replace f of x by simply using your y letter. So as you can see on a rational function, there is an involvement of two variables, y to another side of your equation and to another side of the equation, the ratio between your two polynomials. So that will be a rational function, wherein your phi of x and your q of x should be a polynomial functions, and your q of x or your denominator is not equal to 0. If that is the case, then the given is a rational function. So for additional examples, determine whether the given sentence is a rational equation, rational function, or a rational equality, or none of these. So it can be none of these. So there are cases wherein our answer is none of these, meaning to say the given does not fall under your rational equation, rational function, or rational inequality. And it is possible that our answer is none of these. For number 1, so x plus 5x minus 1, as you can see here, your left side is a polynomial functions. Both your numerator and denominator are polynomial functions, wherein there is an involvement of y, so we can replace this y as f of x. That's why this number 1 example is a rational function. Why? Because there's an equal sign here between your left side and right side. Your one side is a fraction that will represent both your numerator and denominator are polynomial functions. Wherein the another side is y. This y can be used to replace f of x. That's why I always said this, or say this, I mean, that if you're dealing with rational function, you're just simply dealing with two variables involved. Wherein the another side is all about your y, and the another side of your function is the ratio between your two polynomials, wherein you need to check if your denominator is not equal to 0, then it is a rational function. If the denominator is equal to 0, then this given is not a rational function. So because of the symbol y, it is also representation of the function of x or f of x. Yes, it is, no. We just simply replace f of x by simply using your letter y. That's why in dealing with your rational function, again, you're dealing with two variables involved, your y and x, wherein your y for to one side of your function and x is the variable, no, involved in the ratio between your two polynomial functions. And for number 2, square root of 2 over x plus 1 less than or equal to 3 here is the given. Why is that none of this is the answer for this? So this example does not fall under your rational equation, rational function, and rational equality. The answer is none of this because here at this moment, no, your numerator here is not a polynomial function. Why? Because there is a radical sign. If there is a square root sign here, you cannot consider that your uh, term is a polynomial. Why? Because this one can be expressed by 2 raised to 1/2. So we define your polynomial wherein your exponent 0, 1, 2, 3, 4, and so on, but not equal to 1/2. So meaning to say, if there is a radical sign in your term for your numerator or even in your denominator, as long that there is a radical sign, we cannot consider this numerator as a polynomial function. So therefore, this entire term, your fraction here, is not a part or not a ratio of a polynomial functions. So your numerator is not a polynomial function. Your denominator is a polynomial function. We should check first if both your numerator and denominator is a polynomial function. So if one of them is not a polynomial function, then we cannot consider this as a rational expression. Or if we look for this, even if no, even if your symbols here, it shows inequality, no, between your left side and right side, it's still that your one side is not a rational expression. Why? Because there is an involvement of radical sign, which is your square root sign. Therefore, your numerator is not a polynomial function. Then the given does not fall in any of these equation, function, or inequality. So our final answer is none of this. So for activity 1, you conducted an outreach activity to help the needy in your community and have solicited 52,000 pesos. You wanted to propose a plan on how to equally divide the money and the possible relief goods that will be included if you will make a proposal. What plan will you do? So, show your plan by filing up the form below. Outreach proposal, total amount solicited, rational function model, possible number of beneficiaries, amount allocated, and relief included. For activity 2, we just simply use the concept of your rational function, rational equation, and rational inequality, or none of these. So we're asked to determine if the given is a rational function, rational equation, rational equality, or our answer, no? Our answers can be or can fall, no, for none of these, because there are some scenario or some givens wherein this given are did not fall, no, does not fall on your rational function or rational equation or even in your rational inequality. So your final answer can be none of this. Thanks for watching. Please like and comment, and please do share and subscribe.